Hello everyone, good evening. I hope I'm audible to you all.
Hello, sir. Yes.
Yeah, you can text in your group or somewhere for other people to join in as well. So with your request, guys, I got the timing to be modified, right? So I think this is more suitable for everyone.
Yes.
Yeah, 7 to 8 kind of timing will work, I guess, for everyone. Okay. So um today, we'll be discussing on some more hands-on. In the last session, we primarily focused on the setup, on the basic functionalities of MySQL. And in this session, we can dive into some more intrinsic concepts. So what has been, catch me up to speed with what is going on in your regular sessions, guys? What concepts have been covered? And please do text also in your group for others to join in. Yep. So what concepts have been covered in the regular sessions, guys, regarding SQL?
Sir, I was not available in the last session, but before that, we had covered SQL queries, joins. There was another topic, one more,
Subqueries?
not, I don't know if it was covered in the last session, I don't know, but
Then anyone who was present, can you tell me? Group by has been covered? Yes, guys. You can refer to your LMS if there is if that is maintained on your LMS. Just let me know what topic so that I'll try to keep the hands-on confined to that, and I don't want to exceed those topics. Yes, guys, anyone? Just help me with the topic names or what topics have been covered broadly. Yes, Sneha, can you tell me?
Hello, hi Akash.
Hi, Sneha. Yeah.
Yeah, sorry, didn't get you. What do you want to know?
The topics which have been covered in the last two sessions for SQL in your regular session, in your regular classes.
I'm sorry, Akash. The last session I didn't like attend, so I didn't know that. Can
Okay.
anyone, any other person can help me in that case?
Yeah,
Maybe.
yeah, yeah, yeah. That is, yeah, of course, I'll ask someone else. But
Yeah.
it's not even an advice, just a general thing. Like, in case you're missing any sessions, which is perfectly fine to do, everyone has commitments.
Yeah.
You have a group or something, right? Just take an update, what topics have been covered. You don't need to go through the videos immediately. But if you are aware of the topics in general, I'm not just saying about SQL. I'm just saying in general, if you know what topics have been covered in a session, that will like at least keep in the back of your mind, okay, I maybe need to cover this thing by myself, maybe through videos or some other means, right? Just
Yeah.
be aware. This is for, I heard you are the second person who has missed the last session. So just for people in general, if you are missing sessions, which is fine, you might not even get time to watch videos, which is understandable. Just keep a tab, ask your friends for names of topics or what has been covered in that session. Maybe that session covered things which you already know. Well and good, you don't need to recap them again. Just be aware that these things have been covered.
The last lab normalization was covered.
Normalization, so late.
I think PostgreSQL was covered.
But I think that was covered last week, right?
Performance of SQL performance related optimization.
Last week we have holidays, like Saturday, Sunday. So Sunday was holiday.
And prior to that,
I think PostgreSQL, I think, not sure.
Yeah, sir.
post.
So I can tell you the sequence,
Yeah,
okay?
yeah, please.
Last four classes, okay?
Yes.
I don't know the last class, but overall, it started with Postgres SQL commands.
Okay.
Then we moved to joins. Then
Okay.
we moved to normalization. And then
Uh-huh.
the fourth class I missed. I don't know that. I think it was in extension. What I could sense is that it was a performance or something like that.
No,
So
performance
Performance
will be covering
optimization.
later. He is covering next week.
Okay. So
okay, so
what
what
was
what
covered then
what
in
was
that
covered
last
in the
session?
last lecture? Yeah.
And why so many people missed the last session? Any holiday was there? I might not be aware of it. Any public
Yes,
holiday or
Sunday
something?
was holiday, so Saturday missed the class.
Okay. Okay. Okay.
Mahavi,
Hmm?
Mahavi Jayanti also. So we didn't have any classes on Sunday.
Okay. So Sunday there was no class. So I think then what Vipin mentioned only those topics so far, right?
Yeah.
So the last being then normalization, correct?
Yes.
Yeah.
Okay. And next up is performance optimization. That's a very good topic. Uh, Please pay attention to that because that is one of the things which will distinguish you from just normal SQL knowing people. Knowing what is good SQL versus just SQL is a bit of a tricky affair. We will also cover that from a practical point of view, maybe in the next week's add-on session. But just be a little more alert in this week's session. And since we have done normalization, we'll see an interesting application of normalization today. I can show that to you. And we will also see, since you guys have seen Postgres, I'll show you some advanced constructs. Not exactly advanced, but at least some rather not so common constructs in SQL, which are if and case statements. So we will see this today. Okay, I think by now majority of the people have joined in.
Yeah, you could start. We are joining means one by one.
Yeah.
You can start
Yeah.
the session.
Starting in a minute. Okay, let me get water and share my screen, and we'll get started with this concept of normalization, practical application of normalization, and then move on to if and case statement. Hey guys, are you able to see my screen?
Not yet, sir.
Let me reshare the whole screen then. How about now?
Yeah, has come.
Yes, sir.
Yes, sir.
Okay. Yeah. Start with a blank canvas. So, you guys might have learned about the types of normalization, right? How many typical normal forms are there?
4.
4.
What are they?
They are very much like 4, 5, 6.
First,
But
second, and third.
typically
Four.
1NF, 2NF, 3NF,
3NF,
BCNF.
4NF.
BCNF, most
BCN.
common one. Yes.
Yeah.
And then theoretically, there is still 6NF, 7NF as well. But at least still BCNF is widely used. Now, what is 1NF quickly?
Where we
First of
maintain
all,
the
wait.
accuracy.
Before we go into even the normal forms, what is normalization? Like the usefulness of normalization. What is normalization? How does it help?
It avoids redundancy in the
to,
table.
to maintain the acid properties.
No, without normalization also you have acid properties. Suppose I keep the tables in 1NF, I still get acid properties. I do not have to take it to 2NF, 3NF, etc. Even if I don't follow 1NF also, I get acid properties.
Sir, process of organizing the data in a database, we have to
What do you understand by optimizing the data? Sounds a bit jargon.
organizing, sir,
Like redundancy
organizing,
should be reduced.
like,
Yes, now you are coming closer to the point. Redundancy. What is redundancy?
Redundancy means repetition of the data. Like you are storing some data related to a student about his
Mhm.
fees and his class information and his marks. Okay,
Huh?
and now you are updating his class that this student has been, and that student is also having some roll number, and now you are moving that student from that standard to the next standard. But you are doing the changes in a single table only. But for the finance and for the class, for the marks for them it's remaining. So in that case there is a redundancy which goes like means unequal data, inequality in the data that causes means
And what is
updation.
1NF? What is 1NF?
No multiple values in a table.
Come again.
There cannot be multiple values in a single column in a single yeah, because, right.
Single
One value
attribute.
in a one cell.
Okay. Anybody else? See, more people answered when I asked what is 1NF as compared to when I asked what is redundancy, which is the basis of normalization. Okay. I knowingly ask that question and I do it in interviews as well. Even when I consult for, let's say, Fortune 500 companies, if I am taking interviews, I do not start with very complex problems. First, tell me two questions on basics, like what is redundancy? And 90% of the people are not even able to answer that, right? That is because in our pursuit for knowing more and more, we forget the fundamentals sometimes. Okay. I'll give you a very simple example to understand redundancy. Okay. Consider a table. Okay. Cars. Okay. Let's consider a table cars. I will not take a lot of columns in this. I will only take 3 columns. Okay. 3 columns. To explain redundancy, this is enough. Okay. First column is, uh, let's say, car name, the name of the car. Okay. Second column, car company. Okay. Then third column is car ID. Let's say this is the primary key. This is the ID of the car registered in the global database. Every car will have, let's say, unique ID, right? So car ID can be, let's say, C101. I'll take 4 cars. Okay. C102, C103, C104. Okay. Car name, let's take Swift Swift Desire, and let's take Verna and Creta. Okay. Company, Suzuki. Suzuki, Hyundai, and Hyundai. Is there data redundancy in this table or not?
Yes, in the company column,
Yes,
No redundancy.
there is redundancy. What do you understand by redundancy?
repetition in the
Yes.
company column.
Yes.
Like company name is repeating.
Redundant. Yes. Redundant is equal to repeated. Do you see repetition here or duplicated? So, are these not duplicate data? Yes,
Yes, sir.
correct.
Yeah.
This
Yes,
is
sir.
this is data redundancy. This is data redundancy exactly. Repetition of data is data redundancy. And I have taken actually a very small table. So it's repeating just twice. In a realistic table, it will repeat a lot more times. What is the problem with repetition then? Okay, this is redundancy, but why is it a bad thing? Why is it not desirable? What is the problem with redundancy? Anyone?
It takes a lot of space.
Let's consider each character 1 byte, standard computer notation. In Suzuki, you have six bytes, 6 bytes, 6 bytes repeating over and over and over again. Let's say it's repeating 10 times, 60 bytes, 100 times, 600 bytes, right? You are getting it. And now for big data, let's consider things like Facebook, repeating millions and billions of times. How much space are you wasting? And also searching operation, is it slower on text or not?
Yes, sir. That will also be slower.
Yes. So not only not only wastage of space, increasing of complexity also unnecessarily, right? Easy fix for this. Okay. Forget normalization. Let's first understand the origin of normalization. Okay. Why was it needed in the first place? Easy fix for this is I will convert this or split it into this structure. This one table. Now I split it into two tables. Okay. I keep a table called cars. I create another table called company or manufacturer. Okay. Manufacturer. I take two columns in this. One will be manufacturer ID. Second will be manufacturer name. Okay. 1, 2, let's say Suzuki and Hyundai. There are multiple advantages you will get by this. Let me show you. Okay. Let's take car ID, car name, and then finally, let's take manufacturer ID. So MID. Okay. Car ID C101, C102, C103, C104. Now, many people say what is normalization? The easiest or the straightforward definition that comes out of their mouth is uh, avoiding redundancy or reducing redundancy in the data is normalization. So you will think that normally whoever will hear this definition will think that uh, redundancy is totally removed, eliminated by introducing normalization. You will see I have done normalization here, but it's not that redundancy is removed. It is actually mitigated. Okay. It's never removed because even in this case, I will repeat data. See this. I am repeating data, but it is a much better scenario. Why? Who can explain? There is still data repetition. The ID is getting repeated 1122. But this is a much better situation than before. because of two reasons. The same two demerits we discussed. First, integer is fixed in size, and typically fields like ID, they take only fixed size. That is in a general system either 2 bytes or 4 bytes, or if you're implementing it as tiny int, then even 1 byte. So 2 bytes, 2 bytes, 2 bytes as compared to 6 bytes text. This is a small text, so 6 bytes. It can be very large as well. Let's say 20 bytes, 40 bytes, 100 bytes. Who knows, right? So you are saving a lot of data over there. Second, searching through integral fields is much more optimized as compared to for text scanning. So it is also going to be a little bit faster when you are doing things like indexing or searching from using this field. So it's not that redundancy magically made the or normalization made the redundancy disappear. It's that it now made the situation a whole lot more better. And other advantages you can get. Let me now go deeper and deeper. So let's say, uh, imagine I had another column here. Okay. Called origin country. Okay. Origin country means, let's say Suzuki, it's a Japanese brand. So Japan, Japan. Hyundai, Korean brand. So not South Korea, South Korea. Now, these two are also, this is also redundant data, but this redundant data doesn't really have to be here, because in this normalized setup, I will write it after normalization. Okay. In this normalized setup, I can actually move the country details or the origin details out into this table where it is more suited. So in a nutshell, normalization is nothing but actually moving towards proper organization or segregation of data. If you are keeping your table like this, you will still represent the same data. Okay, you are not losing any data. If you do it in two tables like this, you are still maintaining the same data. You are still, there is no data loss between the two formats. But the second format is superior to the first because repetition of data is now significantly less. In this case, it was double the redundancy. Two columns were redundant. Here, only one column is redundant. Direct advantage. Just by repeating the manufacturer ID, you can get the name of the manufacturer as well as the country of origin directly. So redundancy reduced. Now consider other columns also like this. So the more you expand this scenario, the more you will start to understand and appreciate the advantage of normalization. Other than the benefit that I told you, first of all, that integer is better to repeat, right? You also get the more dependent fields there are, the more you can move out into a different table, the lesser the redundancy in the base table, in the original table. And these are all advantages, or you can say positive results of normalization. The disadvantage or a slight drawback is the number of tables actually increases. So some or most realistic operations will require you to use multi-table queries like joins, subqueries, CTs, etc. So that query, writing of query and the readability of query is actually affected a bit because join based queries are slightly less readable than plain queries. So yes, you have that drawback, of course. Your queries will start to look a bit more complicated, but that is absolutely worth it considering especially larger tables and realistic operational situations. Everyone understood what is the need of normalization, where it came from? It is nothing but actually logically how you should be storing data. You should not go for repetition. Forget normalization. You should have stored it in this way in the first place to optimally store the data in tables. So normalization is nothing but just pure common sense. That's the way I describe it. Forget 1NF, 2NF, 3NF. The more you will apply common sense, the more normalized and the more you will move towards normalization. Got that, guys?
Yes, sir.
Okay. And then there are 1NF, 2NF, 3NF, BCNF. Even if you ask me, even after 2NF, even I don't remember the definitions exactly. But the good thing is I don't even have to. For realistic workloads, right? It's not that you will remember the theory and then you will apply it always, going by the rules. There are certain rules of thumbs to operate by, right? You can actually follow those rules, or you can say experiences, and you can very realistically create a very good and normalized database structure. Let's take a scenario. Okay. So I ask you, you have joined a new company, let's say startup, and it's a blogging company. Okay. Microblogging website where users can enroll, post articles, and comment on other articles. The articles can belong to one or more categories. Very simple context. Okay. Consider a very simple version of Quora or Medium like that. Okay. So this is the application. The application doesn't exist. You have to design the database schema for it. Okay. Normalized database schema. Design the normalized database schema for this application. Okay. How do you go about it? Why you don't have to worry about the 1NF, 2NF, 3NF, and how you can still end up with normalized tables. Let us see that. Okay. Now, first activity, whenever you are given a scenario like this and whenever you have to design the database from scratch, first thing you have to do is step number 1, identify the entities. Okay. So what will be the entities? Let's say articles, or I will call it posts. One table will be an entity will post, user will be another entity, correct? Yes. Then category, and of course comment. Any other entity? No. So identify the entities. Step number 2, establish the relationships between the entities. Okay. So what relationships can be there? Okay. What will be the relationship between post and user entity? The type of relationship. Will it be one to one?
2-1.
Will
One to many.
one to many or many to many? Which one will it be?
1.
too many.
Many to
Many to
one
one,
also is
many to
possible.
one, many posts can be associated with single user.
Yes, perfect. So you can consider it like this. User post. Okay. It is a, I'll write it with a different color. It is a many to one. I'll write it many to one relationship. Oh no, in this direction it will be one to many, right? One to many relationship. What does that mean? One user can post many articles, right? So therefore, one to many relationship. What will be the relationship between, since we are considering user and comment?
Same, one to many.
One user, yes, one user can post many comments. Okay. What will be the relationship between, what will be the third relationship? Now, let me ask you guys, what should be another relationship?
Comments and articles.
Post and category.
Yeah,
Post and
post and
Comment.
Post and comment?
Yeah, post and category also.
Yes, that as well. What will be the relationship again?
What's
One to many. Okay. Finally, the relationship last one is,
Post to category.
what will be the relationship?
Uh, one to many again.
1 to 1, maybe.
One to one means what? That only one category can belong to only one post. Is that the case? Let's say I have a category called sports. There can be many posts under the sports category. Similarly, in the problem statement I have given, one post can belong to multiple categories as well. Like you see on Netflix, one movie belongs to horror as well as thriller genre, or one movie belongs to comedy and suspense both. So it's a realistic thing that, or tags on Instagram, one post can have multiple tags. So since one post can belong to many category, and one category can have many posts, so in both directions you are having one to many relationship, therefore it becomes a many to many relationship. Correct? Yes.
Yes, sir.
Okay.
Yeah, fine.
All right. So these are the relationships between entities. That's it. So we have established the entities, we have established the relationships. Step number 3 will be to actually draw the or identify the tables. Okay. Schema. Okay. So step number 3 is to, let's say, create the tables with attributes or columns. Let's keep them simple. So what will be the tables that are required? So we have 4 entities, means we will require at least 4 table. Why I'm saying at least, we will see in a minute. Okay. First table, let's say user table. But here, let me change the ordering a bit. So user, post, comment, category. Okay. First will be user table. Generally, if the entity is singular, table names are in plural typically. So users, because in a table you will hold details about multiple users. That's why. So let's say user ID. Okay. So we are storing user ID here. Then the name of the user. Then let's say things like for logging in, password. Anything else is required, we will add. Otherwise, these 3 things are fine. Okay. This is table number 1. Let's take a few user ID. So let's say U101. Let's take 2 users. U102. Name ABC XYZ. Or let's take a more realistic name. John. Jane. Password. Quality. Now it won't be, password is never stored in plain text in the database. So I will just hash it and store something. Okay. It's hashed and it's stored like a very long password. Users table is done. Then next up we have posts table. Okay. So what are the fields required in posts table? First of all, post ID. Let's say P101 again, P102, P103. Then post title. Let's say post body. Okay. So title is, let's say, A, B, C. Post body, let's say. I'm typing just random gibberish at this point. Okay. Now, how will you represent the relationship between user and post? We have users table, we have post table. The relationship between user and post is one to many. How will you represent it here in this situation, guys? Yes.
So one user can have multiple posts, right?
One
Yes.
user can have multiple post IDs. So
Yeah.
can be multiple.
So you are
Users.
saying I should include a post ID column here, and in that I should have things like P101, comma P102, like that.
No, in a post table, there should be a
Uh,
user.
Correct. If I do this, it is violating 1NF because it is a multivariate attribute. Unlike Excel sheet where we can store maybe things separated by comma, we should not do that in an Excel table, SQL table. So the best way, remember this rule of thumb. If there is a one-to-many relationship, notice in which part or with which entity is the many part associated. Many part is associated with the post, right? One part is associated with the user. Many is here with the post. So go to post table. In the many part of the relationship, you have to create a foreign key to the other table. So if this is the primary key, this will be the foreign key. This will be the primary key. Okay. User ID. Let's say post number 1 is by U101. Post number 2 is by U102. Again, post number 3 is by U101. Done. Your relationship is established. So what is the right way of establishing one-to-many relationship? It's a foreign key in the uh, many part of the relationship table. Okay. Clear with this?
Yes, sir.
Yes, sir.
Then we have comment. Similarly, tell me what will we do for comment table?
Category here.
Well, we are coming to category. Wait. Let's go one by one. So this is comments table. Again, comment ID. Okay. Comments typically don't have any title, so just body of the comment. Yep. Let's say C101, C102, C103, C104. Body again. A. Like most Instagram comments, it is also bot generated. And then at the end, you have, how do you establish the relationship between user? There are two relationships, user and comment, post and comment. How do you establish both of these relationships?
As a foreign key here.
So how many foreign key? How many foreign key will I need in the comments
Post
table?
ID and user ID too.
Yes. Two, correct. So I need two columns here, okay, which are going to be 5 foreign keys. So the post to which the comment belongs and the user who made the comment. Okay. So let's say C101, 102, both are on post 1. So P101, P101, P102, P102, and P103 has no comments so far. Okay, so I can give 3 of them to one post. User ID, different user ID is made, different posts. U101, U101 again, U102. This one was made by U101. That's it. So you have now also established the other 2 relationships. So 3 out of 4 relationships are done. Okay. Now coming to category. So every post will have categories. How should I represent the categories? Should I include a column here in the post table? Let's say my categories will be sports, entertainment, health.
Separate
Well,
table. category.
if I do it like this by adding a column here, let's say first article belongs to both sports and health category, I will have to use a comma to separate them. Again, it is violating 1NF. It is a multivariate attribute. So I can't do that. Then what I do?
We can create another table for the categories and
Okay.
foreign key as post IDs.
Okay. So we create another table, and rightly so, for categories. So let's say category ID. Okay. And category name. Let's say I will take 3 categories. Sports, health, 4 categories. Entertainment and trending. Okay. 4 categories. Now, how do I represent, let's say the first article, first post belongs to 2 categories, sports and health. How do I represent that information?
Multiple rows with specified category.
Huh?
Post ID should be
Should have distinct rows for distinct category.
I have
Post
already
table.
have distinct rows for distinct categories, don't I, in categories table?
In post table.
How can I have? I cannot repeat the whole post data again. So you're saying if I have category here,
Only
let's
the post ID is needed for this in a
Maybe
category.
go to
category
post.
Foreign
ID.
key,
No,
okay.
good. It's good. It's good. Only the post ID is needed. Yes, you are
Yeah.
right. Mhm.
To create another table, I guess, with the post ID and
Perfect.
category ID.
Yes. Yes. That's why I kept the many-to-many relationship at the end. See, I told you in the many part of the relationship, we create foreign key, right? Here the many is with both of them. So should we create just 2 foreign keys, one here, one here? Makes no sense. Okay. So for many-to-many relationship, we will need one more rule of thumb. That is, we need a pivot table or a joining table. Okay. So let me show that to you. This table is not related to any entity. So far, all the tables we have created were one-on-one representation of some or the other entity. That's why I told you we will need at least 4 tables. If there are 4 entities in our system, we will need at least that many tables to represent one for each entity. But we might need extra tables like this for representing many-to-many relationships. Okay. This is going to be a very, very, very simple table. Okay. Doesn't require anything fancy. In fact, it's going to have just 2 columns. Okay. The name of this table will be post categories. That's it. First table name in singular, second table name in plural, post categories. If you have something like this, just from the name also you can tell that it's a special type of table. What is this table called? This is known as,
So one post can have a multiple category, is that? So
Yes.
that's why
Yes.
we are okay.
Yes. One. That's what I have established here in the context, if you remember. The articles can
Okay.
belong to one or more categories. Okay.
Okay. Clear.
Let's just word it a bit better then. Each article, or each post, let me write. Each post can belong to one or more categories. Okay. So this is known as a pivot table or a joining table. Clear? So the columns needed here are what? What columns are needed, guys?
Post ID and
ID and category ID.
category name.
ID and category ID.
Correct. Post ID and category ID. And both of them are foreign keys or not? Both of them are
Both are
foreign.
primary keys.
No, both of them are foreign keys. The
So for
combination is primary key.
okay.
You don't need to make anyone as primary key or a separate column as primary key. If you don't create a primary key for a table, the entire combination of all columns is taken as primary key, and that is fine. It's always going to be unique. So, for example, if
So
I have
it's not because what I've heard is like in every table there must be a one primary key. So it's not necessary, is that?
there is a primary key, as I told you, if you don't create a primary key, the
Okay.
combination of all columns in the table becomes the primary key. So
Okay.
this is the
Okay.
composite primary key
Okay.
automatically.
Composite. Okay. Understood. Because somehow generally this question generally asked in an interview. That's why I asked. Thank you.
So P101 belongs to two category as 1 and 2. Yes, that information is represented. Let's say P102 belongs to entertainment and or health and trending. Let's say news about COVID. So 4 and P103 just belongs to entertainment. That's it. You can represent this information. Clear? Minimal redundancy, and yet you have the same data. Perfect.
One question, sir.
Yes.
Is this case applicable when the post can belong to more than one categories?
Correct.
If not, then there was no need, right? We could have
There
just
was no need. Just adding a category ID foreign key here, column, would be sufficient. Because then the nature of the relationship would be different. Whether you need a pivot table or joining table or not is dependent on what kind of relationship is established. That's why I did step 2 first. If there is a many-to-many relationship, you need a pivot table. If there is no many-to-many relationship, you don't need a pivot table. Simple.
Okay. Yeah.
Got it?
Yeah. Yes. Thank you.
And now if you go back and see all of these tables, whatever theory you have learned in normalization, we didn't pay attention to any of them, but you will see this is already normalized structure. Now, if you follow these rule of thumb, sometimes you might violate BCNF, sometimes you might violate 3.5 NF, sometimes you might violate even 3 NF. But that's no 3 NF you will hardly violate, you will not violate. But BCNF 3.5 NF, sometimes you might violate on some level, but it's fine. Okay. What matters sometimes, or even practically a lot of times, is that the database should not be like the textbook version of a perfect database. It should also be usable by the team. It should not be decomposed to such a level that it becomes a pain to use, that it becomes not feasible for you to use it. Because if you go on doing over normalization, your queries will become less optimal. You will learn that in query optimization as well. The more normalization you do, essentially you are just creating more and more tables. That's what normalization is. The more tables you create now, in order to get a basic information, you will have to combine multiple tables together. And how do you do that? Joins, subqueries. So all your queries will start looking bigger, more complex. For getting simple information about, let's say, user, you will now need to combine two, three, even sometimes four tables if you are normalizing for the sake of it, right? So you will end up causing more harm than advantage. So even if that's why in theory we have 6NF, 7NF, but we don't follow it. Because yes, it exists in research paper, but it's only good in research paper. In practical applications, if you start doing that everywhere, you will not have applications worthy of being of use. So you will only use normalization to a reasonable degree until you get an advantage. Over normalizing is in fact a bad practice. In fact, with modern gain in performance and storage being cheapest ever in history, even normalization is now being not considered also. There is a very important interview question as well as an industry trend of moving towards denormalization rather. So many of the modernization projects, even I have consulted for many, like a modernization project was being taken up by Optum, United Health Group, where they moved from their legacy Oracle database, which was set up in the 1999 or 2000s, to a more modern Postgres setup. They started this project in 2018. It's still ongoing. Was slated to be completed in 23. Now slated to be completed by end of 24. So what they did was, when moving from Oracle DB to Postgres, right? They combined a lot of these normalized tables into one table. The reason is that over the years they have seen, let's say you normalize tables, but 80%, 90% or more of your queries always end up requiring those two tables together. Let's say, to give you an example, 90% of the queries end up using post and categories table together. Whichever query uses posts, almost 9 out of 10 queries also need categories. 90% of the queries. Then what was the point of splitting them in the first place? Anyways, you have to join them. Extra overhead for the query engine, extra process behind the scenes. Right? Anyways, you are combining them in 9 out of 10 scenario. So why split them? Yes, you are getting theoretical avoidance of redundancy, but what is the practical advantage you are gaining? So you have to analyze your queries, analyze the behavior of your system, and then take these decisions. There aren't any textbook rules for this. It depends from system to system. In let's say another setup, only 2 or 3 out of 10 queries use both of these tables together. In that case, it is perfectly fine to go with normalization. It depends on system to system. They found many of their queries require such combination of tables together. So they ended up denormalizing it. Then ended up combining these tables into one back again. So it reduced the number of tables, it reduced their architecture complexity, and it sped up their operations rather. Now they need not write joins again. They need not write subqueries. If you are using joins, you have to know about direction of joins. You have to know about query optimization. You have to know about indexing. All of these headaches are now gone, right? So they ended up gaining a lot of advantage indirectly. So these kind of practical scenarios also you have to keep in mind. It's not that you will always follow the textbook and do normalization. Denormalization is the opposite of it, where you combine two or more tables. It increases redundancy, yes, but you get practical benefits like the one I mentioned, where you do not have to bother about query optimization, about combining different using multi-table queries, and other such things. Clear about this, everyone?
Yes, sir.
Yes, yes, sir.
One thing I want to ask, that denormalization could be benefit when we have to fetch the data only, but whenever we have to do the updation in the data, or we want to replace something, then in that case that will be a very time complexity will be high in that situation.
Yes, naturally. But then again, yeah, they denormalize these tables considering they were more read heavy than write heavy, right? So if it's a write heavy table, then probably not a good idea to denormalize. Depends on the scenario. Similarly, same scenario you will also have to consider when you are doing indexing. If you want to index a column, you can't index it blindly. You will have to check if it is a read heavy or write heavy table. If it is much more of a write heavy table, like let's say posts table. Posts is a very write heavy table. Consider Instagram post and all, people are posting all the time. Or more than posts, think about comments. Even more a write heavy table. People are commenting even more frequently than posting. So you should probably not do a lot of indexing on that table. It will end up slowing things down in the bigger picture. Again, a call that has to be taken from scenario to scenario.
Sir, what is right heavy and read heavy? Can you just brief?
Simply tables where more operations are happening or more read operations are happening. Simply. For
Okay.
example, here we have write heavy and read heavy table. Users are registering one time, right? You sign up one time, correct? But you log in a lot more times, or your information is read, like your name is read a lot more times. This is a read heavy table. How many users do you think are signing up to a platform every day versus how many are logging in or using it? Consider
Mm.
Amazon or any top application. Users is always going to be a read heavy table versus comments. People are reading comment, but people are also commenting a lot. Likes, for example, if likes column is involved anywhere, heavily write heavy table. People are updating likes, liking, unliking, frequently like. So if you consider the ratio of read to write operations, almost going to 50-50 or more than even 50% of the operations are write operations, in fact. Right? Similarly, posts, debatable, depends on system whether it is write heavy or read heavy. Categories, again, a read heavy table. You are not going on creating categories every day. You will define some 4, 5, 6 categories and it will probably remain the same. It will
Yeah.
almost become a static table after a while. Static table means a table whose data doesn't change over time pretty much. uh,
Okay.
Simply, these are different kinds of terminologies used for tables depending on the kinds of operations you are performing. Clear?
Yeah, clear. Thank you.
Yes, sir.
Okay, everyone understood normalization and these rules of thumbs depending on the kinds of relationship?
Yes, sir.
Yes.
Yes, sir.
Sir, it is a normal practice to create a pivot table for many to many
Yes, pretty
relationships.
normal practice. Even you will be asked in interviews if you are applying for a database heavy scenario, they will give you a scenario and ask it to you. I have been asked this in my initial years as well.
Okay.
Okay.
Yes, sir.
Okay, now there is a small exercise that I'll give you guys as homework for normalization. Okay. You can apply these rule of thumbs or the theory that you have learned in your sessions or both to do this. Let me just show it to you. And are you able to see the browser window?
Yes, sir.
Consider this not normalized table, okay, with the data. You have to first convert it to 1NF, 2NF, 3NF, and BCNF. Beware, not all normalizations might be possible. Okay, you have to then justify why not. Got it?
Yes, sir. So we
Yeah.
have to just create a normalization table.
Yeah,
which is
normalized structure, database
normalized
structure.
structure.
Right. Yeah. Right now the database contains one table. This one. You have to
Yeah.
normalize the database
Okay.
step by step. 1NF, 2NF, 3NF, and BCNF.
Whichever
Okay.
is applicable.
Whichever is applicable. Correct. So finish it by the next session. This will give you a small practice also. How you can submit the solution. You do not have to wait till the next session. If you have a GitHub account, like I told you, right? If you come to this repo, you can scroll down. You have comment here, right? Let's say you do this on a database diagram tool. After that, you will get the database diagram. Or let's say even if you do it on pen and paper, or if you do it on Word, Notepad, no, doesn't matter where you are doing it. You can take a screenshot or you can take an image. You can upload the image or even drag and drop the image here and comment. That's it. Okay.
Okay.
Yeah. Best way to actually would be to, and it will give you an additional layer of practice is you can try creating this table using create table command and run insert into commands to insert this exact data. Then write commands to create more tables, normalized tables, write alter table command to change this table. So this will be a lengthy process, but it will be good practice. Why am I saying it will be a good practice to do it right in Workbench or through commands itself? Because let's say you are working on a modernization project, you get into a new project, and this project is an upgradation modernization project. You have a table like this, you have to normalize it. You can't do it on pen and paper, and that would be it, right? You actually have to write working queries to make it happen, reflect it in the system. So if you start by practicing, you can do it first on pen and paper, but try doing it by creating this table on your database server and try doing it through commands until you reach the normalized structure. That will be really good practice. If you can do that, if you can paste all the commands here, that will be really good.
So, sir, there is a one student, Sarah, and there is a multiple books, right? Until the day I die,
Yes.
Inceptions. Okay,
Yes.
cool. Okay, okay, okay.
Clear?
Yes, clear.
Okay. So try doing it through commands, like I told you, step by step. Will take a bit more time, yes, but will give you a realistic workflows experience, and it will be quite handy if you do that. Okay.
Okay, sir. Thank you.
Okay, sir. We'll try that.
Yeah. Try if you don't, if it's not possible, I will give you the answers in the next session. Okay, for the normalized structures.
Okay.
Yeah.
Okay.
Sudarshan is a question how to be good in writing queries, even if you understand concepts, feeling tough. Only practice, Sudarshan. The more you see, read queries, the better you will get. That's the only answer. It doesn't come or click immediately. Takes a bit of time. You will try, you will fail, you will read the answer. You'll try, fail, read the answer. Just like getting good at maths. There is nothing if you are not able to think of the solution naturally. If you do it more and more, it starts developing as a second nature. So that's the only answer. There is nothing that, other than that, there aren't that many tricks. There are some visual tools and all, but I personally haven't found them to be useful. Just write queries, analyze them, try to understand why the solution was written in that way, and your brain will slowly start picking it up involuntarily. It comes with a bit of practice. All right, then. Thank you, everyone. I'll see you over the next week.
Thank you.
Thank you, sir.
Thank you. Thank you, sir.
Thank you, sir.
Thank you.
Yeah. Thanks.